Hi dears, welcome to my channel. Today we are discussing class 8 11th lesson chemical effect of electric currents. Which means what? Which means what are the chemical changes or chemical effects which are caused when electricity is passed through substances. Okay, this we are discussing in detail in this lesson. What was the 10th lesson? It was sound. Do you remember there at the end of the class I have asked you 3 questions. It's the time to answer these questions. The first question was the loudness of sound depends on. The loudness of sound depends on what ma? It is depending on amplitude. Second one was unit of loudness. What's it? It's an easy one. It is decibel. And the third one was an optional question. Which of the following instrument produce sound through vibration? Options were ghatam, flute, sitar, tabla. Sitar is making sound. Now we are seeing the lesson number 11, that is chemical effect of electric currents. Okay. When we are saying about the electricity has to be passed through something, isn't it? We have already learnt about the conductors and insulators. What are conductors? Conductors are the substances which allow electricity to pass through them or electric current to pass through them. And what are insulators? Insulators are the substances which do not allow the electric current to pass through them, isn't it? So, based on that, we can say conductors conduct electricity and the insulators do not conduct electricity. So, how the conductors are conducting electricity? We are seeing here. How the conductors are able to conduct electricity? When we are thinking of it, we should go to the atom structure. What is the structure of atom? Atom consists of proton, neutron and electron. We have already learned, isn't it? Proton and the neutron should be at the center and we are saying it as nucleus. And the electrons are the one which revolve around the nucleus in a circular path. The outermost electrons of the atom are responsible for conducting electricity. How? If the outermost electrons of the atom are allowed to move freely, it will conduct electricity. Okay? This is the only criteria for it. If the outermost electrons are able to move freely, these outermost electrons carry electric current through it and they will conduct. So these substances will be said to be what ma? Conductors. We all know that copper is a good conductor of electricity. So what will happen when electric current is passed through the copper? We should see. Copper, when electric current is passed, it will split into Cu2 plus 2 electrons. These 2 electrons is in every atom, 2 electrons will be free. This 2 electron will carry electric current from each atom. So we can say that the copper is a good conductor of electricity. And moreover, in this metal, the resistance is very less. What is resistance? Resistance is acting as a barrier which opposes the electric current. If the resistance is more and more, the conduction will be very less. Okay. So if the resistance is less, conduction is more. Here in the case of copper, resistivity is very less. Means what? It will conduct electricity more. So copper is said to be good metal. Okay ma? This is how we have to join the conduction and electric current. Okay. So in the case of insulators, what happens? In the case of insulators, even if we are applying electricity, free electrons are not produced and moreover resistivity will be very much increased. So because of these 2 reasons, they will not conduct electricity. So they are said to be what ma? They are said to be insulators. And how will we say that the substance is conducting or not? By connecting a circuit. Here a circuit diagram I am drawing for you. See, this is a circuit diagram. Here electrical source, that is a battery, is connected over here. Then a bulb is there and a metal is connected here. Here a metal is there and this is the switch. If we are switching it on, if metal is there, the free electrons will be present and it will allow the electric current to pass through. So what happens? The bulb glows. So we can say that this will be what ma? This is a good conductor. If we are changing this metal to a piece of rubber, what happens? What happens? The rubber is not having free electrons in it. So it will not conduct electricity. So the circuit is not closed here, it will be opened. The circuit is not closed. So what we can say is will the bulb glow? The bulb will not glow. And we can say that this rubber sheet or the rubber piece is an insulator. Like that, we can check whether the substances which we are having as conductors or insulators by this. Okay. Okay, up to this extent we have said about the solids, isn't it? In the solid cases, we can say whether they are conductors or insulators by keeping them in this place. Again, by keeping them, we can check whether they are conductors or insulators. Now, in the case of liquids, will they conduct electricity? Will the liquid conduct electricity? How will you come to know whether it is a conductor? This liquid is a conductor, this liquid is an insulator, like that. How will you know? The same thing we have to apply for the liquids. But here we are changing. Here I have changed. See, this is the liquid which we have to check whether it is a conductor or not. Okay. These are the two things which we are dipping inside. We are saying it as electrode. What we are saying, ma? We are saying it as electrode. Electrode should be always a metal, a good conductor. It should be always a good conductor of electricity. These two electrodes, it is a must. And here again the battery is connected, and here this is a positive terminal of the battery. This positive terminal of the battery is connected to an electrode. We are saying it as anode. This is the positive terminal, positive electrode. We are saying it as what, ma? This is said to be anode. And here this is the negative terminal of the battery, and it is connected to an electrode, and this electrode is having negative charge, and we are saying it as cathode. Okay. So this is the anode and this is the cathode. This is the positive terminal, like this is having the positive charge and this is having the negative charge. And this liquid which we are checking whether it's a conductor or not, this is said to be what, ma? Electrolyte. Electrolyte. This electrolyte, if it is conducting, the circuit will be closed, isn't it? Through this electrolyte also the electric current will be passing and this circuit will be closed, and which results in the glowing of this bulb. Okay, if the electrolyte is a non-conducting substance or non-conducting liquid, what happens? This bulb will not glow because the circuit is not closed. By this way we can say whether the liquid is a conducting or not. Okay, now we are adding pure water or distilled water as electrolyte. Will it conduct electricity? The answer is no, it will not conduct electricity, because in the distilled water, splitting of ions will not take place. So it will not conduct electricity. So how can we make the water as conducting one? We can make the pure water or distilled water as a conducting one by adding acid or bases or salt. Okay, by adding either acid, if we are adding water plus HCl, which is a strong acid, or a weak acid even, CH3COOH, then also it will conduct electricity. Even if we are adding a strong acid or a weak acid, a little only, if we are adding, it will start to split into ions and it will help for the conducting electricity. Okay, by adding acid or by adding bases, NaOH, it will conduct electricity, or by adding salts, even NaCl. If we are adding some common salt to the water also, it will start to conduct electricity. Okay, by this way we can change the water as a conducting one. So my question is, if we are adding a little sugar to the water, will it conduct electricity? No, it will not conduct electricity. If we are adding sugar, the splitting of ions will not take place and it will not conduct electricity. The formula of water is H2O. 2 hydrogen and 1 oxygen combined to form what? Water. So what happens when electricity is passed through the water? It will split into hydrogen gas as well as oxygen gas. And this process is what, ma? This process is said to be electrolysis of water. Splitting of water into corresponding gases is called what, ma? This is called the electrolysis. This process is called electrolysis. By this way, hydrogen gases can be taken up and oxygen gases can be taken. So how is it happening? We can see. Now we will see how the water is splitting into hydrogen gas as well as oxygen gas when electricity is passed. This process is called electrolysis. What is electrolysis? Electrolysis is the chemical effect which is happening to the solutions or liquids when electricity is passed. Electrolysis of water means what, ma? The splitting of water molecule into hydrogen as well as oxygen when electricity is passed. This is the apparatus. Okay, ma? In this, as the electricity is passed, one is acting as the anode. This electrode is acting as the anode and this electrode is acting as the cathode. So the water which we have to be separated should be acidified. So we are taking acidified water. Okay. Then what? Then a test tube has to be kept above this anode and one test tube has to be kept above this cathode also. Actually, this should be separated by a membrane because the oxygen gas is explosive, highly explosive. So, if we are doing in laboratory, much more precaution will be taken while we are doing this electrolysis of water. So, what happens is, when electricity is passed, in the anode, the oxygen will be collected, and in the cathode, the hydrogen will be collected. Actually, in the anode part, oxidation occurs. That is, electrons will be separated out from the metal to form free electrons. And this free electrons will be moving and collecting in the cathode. In the cathode, reduction occurs. So, oxidation is occurring always in anode and the reduction is occurring always in cathode. So, here we will see what is the reaction and how is the separation of the oxygen as well as hydrogen is occurring. See here, at anode, what is going on? 2 H2O molecule, 2 molecules of water get split into 4 H plus ion and 4 electrons, and oxygen is liberated. This oxygen is collected over here. And then in cathode, what happens? In cathode, these 2 electrons combine with the hydrogen to form H2 plus 2OH minus. So, hydrogen is collected at cathode and oxygen is collected at anode. So, total reaction give you 2 molecules of water get split into 2H2 plus O2. This is the reaction which is occurring, and the water gets split into hydrogen and oxygen by the process of what, ma? By the process of electrolysis. Is the electricity able to split only the electrolyte? No. It is also helpful for the deposition of a particular metal over the another. Have you heard of electroplating or plated, gold plated ornaments, silver plated ornaments? Have you heard? This actually what happens is, a coating of silver or a coating of gold is placed above that particular ornament to give a jewelry touch of it. See, for example, if you want to plate a steel spoon as silver, if a small coat of silver has to be given to the steel spoon, it can be done by means of electric current. How it can be done, we will see. See here, again, we are considering a beaker, and then we know that electricity has to be passed. Then, as the positive part is here, it should be acting as what, ma? Anode. And this is the cathode. This is the setup. Here, the anode, this is the anode and this is the cathode, and this is the electrolyte solution. This is the setup. See, if the silver has to be coated on the steel spoon in which the silver has to be coated should be always in the negative terminal. So, it will be acting as the cathode. Okay. And the silver which has to be deposited should be always as, it should be always as anode. So, here this is silver. And this is the steel spoon. Okay. Electrolyte also plays an important role. This electrolyte always should be a solution of salt which contain the ions of the metal which has to be coated over here. Means what? This solution should be a salt solution containing silver. Okay. We are taking here as silver nitrate. So here silver also should be present. Here silver metal and the solution should be having the salt of that particular metal ion. So the solution should be silver nitrate and the spoon is steel. So what happens when electricity starts to flow? We know that in anode always what happens? Oxidation happens. So silver gets split into Ag plus electron. So this Ag is split into Ag plus. So metal ion it has become. This metal ion, if the metal is changing into metal ion, it will not be along with the metal again. It will be detached from this metal and moves through this solution and attached to the cathode. Why it is attaching to the cathode? Because cathode is having a negative charge, isn't it? So the positive charge will be always having the tendency to attach towards the negative charge. So Ag plus will move from this metal through this solution and gets deposited over the steel spoon as there is negative charge in the steel spoon. So Ag plus there, what happens is it receives an electron over here and it will be changing as Ag. So means what? Above the steel spoon, silver atom starts to deposit. So if we are allowing the electric current to flow through within half an hour or within 1 hour, we can say the steel spoon has been coated with silver. If we are increasing the time period, the coating will be much more thicker. Okay? If we are increasing the time, the much more silver will be coated above the steel spoon. And what about this metal? This metal will become more and more thinner. After half an hour, it will be like this. Then after 1 hour, it will be much more thinner. Like that, it will be reduced in size and it will be increased in size. So here fully, what happens? Silver metal will be deposited. Okay. Not only for coating silver on the spoon, we can do some other metals. To say copper can be coated on any metal. The copper plating can be done for any metal. See, in that case, in every cases, there should be one condition, that is the copper which has to be coated should be placed as anode, and the other metal on which the copper has to be coated should be always as cathode. Okay, then the solution also should contain what, ma? Contain the salt of that metal ion. Okay, so this copper is the metal which has to be deposited. So the solution should be copper sulfate, CuSO4. So copper will be there, no, in that solution. So that should be the solution. And the fourth and important point is, to which extent, if you are drawing this, to which extent we have to draw this electrolyte is in such a way that the two electrodes should be immersed in the electrolyte. I think this is very important, because if the electrodes are not fully immersed on that part which is outside this electrolyte, the coating will not be occurring. So what happens is, when these two electrodes are fully immersed in this electrolyte, and when electricity is passed, the copper will be split into copper ions, and these copper ions get dissolved or get transferred to the cathode via this electrolyte. Okay, so this is happening, and what happens is the size of this anode will be decreasing, isn't it? Because the more and more copper is losing for this anode. So what happens is that if we are increasing the time, the anode will get thinner and thinner, while the cathode will be what, ma? The cathode will be increasing in size, isn't it? The size of the cathode will be increasing, because copper will be more and more deposit, or any metal which is kept in anode will be more and more deposit on this metal on the cathode. So what happens? The size of the cathode gets increased as the time is increasing during electrolysis, and the anode's size will be decreasing. Okay, so these are the things which are very important. Then what is use of this electroplating? Is there any use for this electroplating? What are the uses? The ornaments can be given a jewelry touch when it is plated with gold and silver. Okay, so silver plated or silver coated bangle, gold coated or gold plated earrings and all you have heard. This will be very cheap, or it will not be that much costly as original gold and silver, but it will be felt as it is the original gold or original silver. So jewelry touch can be given for the ornaments. It is one specialty. And the second is, food can be stored. To say, if we are taking the food, or if we are using an iron box for storing the food, the iron will corrode the food, okay, because the rusting will be occurring, and the iron will corrode the food items itself. So what happens is, it will be coated with a tin. If the tin is coated with it, the food can be stored for a longer time without getting corroded. Okay, this is one other specialty. Third and the important point is to resist corrosion. Iron, we know that when it is in touch with water and air, it will get rust. Okay, so what happens when rust is happening for the iron? It will be damaged. This iron will be damaged and all. So to avoid it, we will coat the iron with zinc. So zinc coated iron is kept in for making bridges and all. So for a longer time, this corrosion will not be occurring. So corrosion can be prevented by doing this kind of electroplating. Okay. Now we are seeing what are the changes which are happening when electricity is passing through the solutions which are conducting. Okay, when the conducting solutions, in the conducting solutions, when electricity is passed, what are changes are happening? Sometimes the gas bubbles will be coming out at the electrode. We can see this is a change. And second is, sometimes the metal will be deposited on the electrode, that we have said, that is electroplating. There is another name for this electroplating, that is electrodepositing. So these metal deposits can be seen in electrode. And the third one, sometimes the color of the solution will be changed. This electrolyte, solution, this color will be changed after electrolysis. And the fourth one is in water, the splitting of hydrogen and oxygen can be seen, isn't it? Electrolysis of water helps for the splitting of water into hydrogen gas as well as oxygen gas. So these are the changes, or these are the chemical effects which are visible when electricity is passed through the conducting liquids. Okay. Now we have concluded. What all things we have learned? What are conductors and insulators? We have learned in elaborate way. Okay. We have seen what is electrolysis. What are the changes which are happening to the conducting solution when electricity is passed, we have seen. Among them, we have seen the electrolysis of water, then electroplating or electrodeposition, and the uses of this electroplating, and what are the uses of electrolysis. What is the use of electrolysis of water? We will be able to separate the hydrogen and oxygen from water. So all these we have learned in this lesson. Now I am concluding the lesson, and this is the question time. First question is, passage of electric current through the conducting liquid causes dash. Passage of the electric current through the conducting liquid causes what? Second one is, electrodes should be made of dash. Third question, negative charged electrode is said to be dash. Okay. These are the questions. I think it's very easy for you to answer. Answer these in the comment box, and we can meet in the next class. Bye.